Okay, this is an examination question on probability tree diagrams. Shilpa Shetty is packing her school lunch. Sorry, just Shilpa. She chooses at random a packet of crisps and a biscuit. There are 3 packets of plain crisps and 2 packets of cheese and onion crisps. There are 4 chocolate biscuits and 8 caramel biscuits. Complete the tree diagram to show this information. Okay, let's have a look. Let's choose a nice red color and let's choose a nice size. Now, if you have 3/5 of them are plain, then automatically to complete the one we need 2/5. If 1/3 of the chocolates are chocolate biscuits, the biscuits are chocolate, then the caramel biscuits will then be 2/3. Oops. Okay, and then chocolate biscuits. So this one again is independent event. So we copy it down again. 1/3 and
2/3.
Okay. So we've completed the tree diagram. Now it goes calculate the probability that she chooses a packet of cheese and onion and a chocolate biscuit. Cheese and onion. So we're going to come down here and then we're going to choose a chocolate biscuit. So we're going to go up here. So it's a combination of this one and that one. So what do we say here? We say it's going to be 2/5 times by 1/3
equals 250. 2 of 15.
Equals 2 over
15.
15 is the answer for that for first part B. Is there a part C on that page?
No.
Is that the end of the examination question?
Yeah.
Lovely. Let's get rid of this and get a new one on. Okay, it's just like you have Excel. It's just like that. So Amy has 10 CDs in a CD holder. Amy's favorite group is edX. edX, this could be some kind of music group then. She has 6 edX CDs in the CD holder. Amy takes one of these 10 CDs at random. Okay, she writes down whether or not it is an edX CD. She puts the CDs back. So this question is called probability with replacement. So the next part, the second choice will be similar to the first. Now, they've decided to do the probability in decimal. Nothing to worry about because 6/10 is equivalent to 0.6. And so opposite of 0.6 is 0.4. Now because they put the series back in, the probability on the second go will be exactly the same as the first one. So they won't change because the series has been replaced. So we can copy them down quite easily. Now the question says find the probability that Amy will pick 2 edX CDs. So that means she's going to pick the first one and then followed by a second one. So we're going to say here it's going to be 0.6, this one, multiplied by 0.6. So it will be probability of edX and the probability of edX, which is 0.6 times by 0.6, which is equal to 0.36. Is that the end of the examination question? Done? So we can write that answer actually down here. Done. Lovely. Right, it's examination question. So revision classes are held after school. Jaya always attends these classes on a Tuesday and a Wednesday. He can choose maths, English or science to study on each day. Probability that he chooses maths is 0.4. Probability that he chooses English is 0.1. Now, what should the probabilities add up to?
1.
Should add up to 1. So we got 0.4 covered, 0.1 covered. So how much is left over? 0.5. So 0.5 will have to go where?
Science.
Yeah, for science. To complete this probability of 1. Now we can replace it here as well. Okay, it's independent events here, so that's also 0.5. That's also 0.5. That's also 0.4, 0.1, 0.5. Now, it says the work of the probability that Jaya chooses the same subjects. Now, I need to expand this here. I'm going to show you some working over here. Work out the probability that Jaya chooses the same subject on Tuesday and Wednesday. Now, anybody give me some ideas what I mean by the same subject? So, the first same subject is going to be what?
0.4.
Maths and Maths. That's one color. The second same subject could be,
English and English.
and the next one could be
Science.
followed by science. So I'm going to do the first one now over here. So the probability of maths and the probability of maths. Okay, what's the probability of maths?
0.4.
0.4 times by
0.4.
0.4, which is going to give us 0.16. Okay, the next one. Probability of both English.
0.4.
Probability English, hang on a second, English. Okay, let's have Mr. Saf. He's just sitting there waiting for all the answers. Come on, go for it.
0.1 times 0.1.
0.1 times by 0.1. Okay, let's see who gets this one right. 0.1 times by 0.1 is equal to?
0.9. 0.01.
Thank you. 0.01. Okay, last one. Probability of science and science. Whoops. Did you?
0.5 times
0.5 times by 0.5. Which gives us?
0.25.
0.25. Now, if you look carefully at the question, we realize here that this question actually involves an or. So the probability of this first one, or the probability of the second item, or this one. So we've got three possible answers. So it's not the first one and the second one. It's probably the first one, or the second one and third one. Because whenever we work out probabilities at the end of the tree diagram, and we've got to look at three separate events at the end, we have to change the or into a into an add. Let's go to this. Add them up. So the probability of getting the same subject will be the probability of getting both maths or both English or both science. So you got 0.16 at 0.01 at 0.25. And that gives us an answer of?
0.42.
Okay, is that checked, verified? You happy with that?
Yeah.
Okay. So the answer here will go as 0.42. And that's an examination question all done. Okay. Let's pause it for a second. Okay, the probability that a biased dice will land on a 4 is 0.2. Pam is going to roll the dice 200 times. Work an estimate, okay, for the number of times the dice will land on a 4. So we're going to do the question 200 times, and each time the probability of it landing on a 4 is going to be what? 0.2. So you have to do 200 times by 0.2. So the way we work that out, you can do change the number into a fraction, if you like. So 200 times by 2/10. So divide that by 10, divide that by 10. We end up with 20 times by 2, which gives us an answer of 40. Sorry. The probability that the biased dice will land on a 6 is 0.4. Ted rolls the biased dice once. Work out the probability that the dice will land on either a 4 or a 6. So if you look at the language of this particular question, so the probability of a 4 or the probability of a 6. What was the probability of a 4 earlier? 0.2. And the mention with or means plus. Probability of 6 was 0.4. Probability of 4 is 0.2. So the total answer is?
0.8.
You sure?
6.
0.6. Yeah? Yeah, add them up, okay? Lovely. Examination question done. Next examination question, please read out to me. So, is it on
The
the
sides of the spinners are labelled 1, 2, 3, and 4. Yeah, that one.
okay? The sides of the spinner are labeled 1, 2, 3, and 4. The spinner is biased. Okay, so it's more likely to land on one than the other. The probability the spinner will land on each of the numbers 2 and 3 is given in the table. The probability the spinner will land on 1 is equal to the probability they will land on 4. So, now what is the, first of all, the maximum probability?
1.
The maximum probability is always 1. So far we have 0.3 and 0.2, which gives us altogether how much?
0.5.
0.5. So how much is left over? 0.5. And if you split that how many ways? 2 ways, because probability 1 and 4 are both the same. So if you have 0.5 and then we divide it by 2, That'll give us what? 0.25 will be the x here, and also 0.25 will be here, and we write over here for completeness. Okay, because all together are equal to 1. Because Sarah is going to spin the spinner 200 times. Work an estimate for the number of times it will land on a 2. So we look at the diagram. The probability of landing on 2 is what?
1.3.
0.3. So we got 200 now. Time by 0.3, which is the same as saying 200 time by 3/10, because 3/10 is the same as 0.3. So what do we do now here? We cancel it down. So divide the bottom by 10, divide the top by 10. So we're left with 20 times by 3, which gives an answer of, what's the final answer? 60 times. You just see that here in brown ink over here. Are we happy with that examination question? Yes? Okay, the next two questions, is it this one here? Amy one.
Yeah.
Okay, the next, okay, this question on the bottom C is more of an advanced question here. C, question C here. I'm not really expecting any of those apart from the students who are aiming for A and A star to be able to get that one right. But I want everybody to have a go at question number 13 and the one that comes after that, please now. Can you try some questions for me, please now? Okay. Amy is going to play one game of snooker and one game of billiards. The probability that she will win the game of snooker is 3/4. The probability that she will win billiards is 1/3. Complete the probability tree diagram. So these are independent events. So let's fill it in. So what do we get here, folks? What do we get here? Tell me. You got 3/4 and 1/4. And I want it red. 1/3 and 1/3 and 2/3. Now, look at the probability that Amy will win exactly one game. So what does that mean? That means she's got to win a game and then lose it. Or she has to lose the game first and then win it. So she can only have one win in the answer. Okay, now, if we look at that, we change now back to this. So the probability of a win and the probability of a lose is equal to 3/4 time by 2/3, which will give us an answer of, come on folks, give me the answer.
6/12. Yeah.
6/12,
6/12.
which is the same as,
1/2.
okay. Now the second one, the probability she won't win first and she wins afterwards will be what? Probability of not winning, which is the same as losing, and the probability of winning. Okay, well, what will give us? 1/4 multiplied by 1/3. That will give us altogether what? Now, what do we do with these two answers? Because we got two possible answers, so it's going to be either this one or that one. So there's an O involved. So what do we do with the two numbers? We have to add this number with.
That one.
Okay, what's a half at 1/12? 7/12.
That's what I said.
Because a half is worth 6/12. Half.
Yeah.
And add to the 12. So the final answer is 7 over 12. 7/12. That's the probability that she will win exactly one game. I'm going to leave this other question out for the moment. We'll come back if you have more time in the lesson. I've got some other questions to do with you at the moment. So it says the Fizzer, okay, she must be fizzing, has 10 coins in a bag. There are 3 £1 coins and 7 50p coins. Fizzer takes at random 3 coins in the bag. Work out the probability that she takes exactly £2.50. Now, let's have a look at what are the different ways we can make £2.50. Take in consideration that she's taken the coin that she's not putting them back in. So this question is going to be probability without replacement. So it's going to be without replacement. Okay, without replacement. This is the question over here. So we've got to work out now. How do you make £2.50? You can either have £1 and £1 and 50p. That's one way of making it. Or you can have £1 and 50p and £1. Are you writing all this stuff down, folks? Are you writing it down? Or what other way could you do it? You could have
£1.
50p first, and then
£1.
£1, and then
£1.
£1. So how many different ways do you have of making this £2.50? How many different ways? 3 different ways.
Or you
So-
could use 5.
So this question will involve what? What will it involve? Will involve an 2 O's. So it's either this one or that one. Go on.
We have another way.
Go on then.
It's 550.
But you can only choose 3 coins.
Oh,
So it's 3 ways.
okay.
Go on. Okay. Okay, we ready for that now? Ready? To do it? Okay, let's write down some basic facts first of all. What's the probability of getting a £1? First of all. Probability of getting a £1 is what? How many are they?
1, 2, 3, 4, 5, 6.
3 out of 10. And that's over here in the question. I don't know what you're counting. Okay. Okay. What's the probability of a 50p piece?
7.
7 out of
10.
10.
How is it 7?
Because it tells you there. Okay, there are 7 50p coins. Yeah, and 3 out of 7 normally gives you 10. Normally does. Anyway. Okay. Right, let's do all this math now. Make it okay. So we are now gonna do the probability. Oh, let's go back to the black. So we can do all that here now. Probability of a £1, probability of a £1, and the probability of a 50p. O means, what do we say? Plus. Probability of a £1, probability of a 50p, and probability. Oops. Probability of a pound. Or the probability of a 50p, and the probability of a pound, and the probability of a pound. I'm setting out here in the bottom so we can now start putting the fractions in. So, Mr. Hassan, what happens to the fraction? What's the probability of my first pound I take out? It's going to be how many out of 10? 3 out of?
3 out of 10.
3 out of 10. What does the and mean?
Add
Time.
Times.
times.
Okay, now that I've taken the first pound out, what's the probability of my next pound?
2 out of 9.
Excellent. Some people are awake today. Okay. Now, I've taken the second pound out. What's the probability of my first 50?
7,
No,
10.
7 over 10.
7 over 8.
We go with 8.
Because you've only got 8 left.
Exactly.
Because you're taking them out. So you have 10 in the beginning, then you have 9, then it's out of 8. Yeah?
Oh, yeah.
Yeah. Oh, yeah. See, nice. Oh, yes, kicking in now. Good, I like that.
I sound lost, you know.
Who does? Oh, no, she does.
Nah, I'm right lost myself.
Okay. Okay, what's the probability of the first pound again on the next one? 3 out of, so we're restarting, yeah? So it's
Why
going
did
to
you
be,
have to add this time?
because it's supposed to be, because it's this first event, it's always there.
3 out of 10.
So 3 out of 10. And what's the probability of my first 50?
7 out of 9.
Yeah.
Probability of my first 57 out of
9.
9. And what's the probability of my second pound now?
2 out of 8.
2 out of 8.
2 out of
Why
8.
does it sound like 7 out of 8?
I'm confused.
So it's 10, 9, 8.
I'm confused.
Okay, we're not confusing a second. Just hang on. Hang on to your Jimmy Dennis.
I get it. Nah, I'm only
What's the probability of our first 50p? If you restart the question at the beginning, probability.
7 over 10.
I'm so lost.
Keep recording, yeah? Okay. 7 out of 10. Time by the probability of my first pound coming out is
3 over 9.
3. Oops, wrong
Out
color.
of 9.
Over 9.
3 out of 9.
Oh. Oh.
Because you've taken one coin out, you've only got 9 coins left.
2 out of 8.
And the last one, the probability of my next pound is going to be 2 pounds left out of 8 coins.
I get it now.
Okay, now what we need to do, we need to start working this stuff out. Okay, here we go. So we have here this one, add this one, add this one. The bottom number is going to be the same each time. 10 times by 9 is
90.
90 times by 8 is
170.
120.
Oh, yeah.
okay, that's right. Each one's going to be out of
70.
720.
okay, what's the top number it's going to give us then? So 3 times by 2 is 6 times by 7 is 42.
Same. It's going to be the same.
It's going to be the same each time?
Yeah.
Okay, what that gives all together? So what's 42 at 42 at 42?
126.
100 and?
26.
Okay, now let's see who's smart now. Who's cancelled down for me? 126 over 720. Let's see who the smarty pants are.
Isn't that 21 or
7 over
They
40.
use a calculator.
I just said that.
It is,
7 over 40.
Well,
Exactly.
what do you get, madam? You got 740 as well? Can you please double check that?
We said it first. Okay.
See the last
you
one.
don't want to
Okay, right. Caroline has 20 biscuits in a tin. She has, okay, she has 12 plain biscuits, 5 chocolate biscuits, and 3 ginger biscuits. She's got ginger biscuits. Caroline takes at random 2 biscuits in the tin, so work out probably the 2 biscuits were not the same type. Remember now, 2 biscuits taken out means they weren't replaced. So the first one, second one, so we have to change the fractions. So let's have a look at what this question entails. Okay, if I can find my mouse, okay, here we go. Now the probability, okay, right, let's choose. The probability of choosing, say they're not the same. Okay. Probability of not the same is equal to 1 minus the probability that they are the same. What's the probability of the same ones, 2 same ones, and not the same ones? They will both add up to 1. So if we just rearrange that equation, probability of not being the same and probability of the same being 1. So this is one way of doing it. It's a shortcut. So rather than working out what you've been told to work out, you work out the opposite thing and minus it from 1. That's like a quick way of doing it. Okay, now, what is the probability of them all being the same? So let's have a look at that possibility. So we have probability of a plane and the probability of a plane, or the probability that we get a chocolate one and the probability we get a chocolate one, or the probability we get a ginger biscuit and the probability we get another ginger biscuit. So what I'm working out here is the opposite of what they've asked me to work out in the question, and I'm going to minus it from 1, and that will give me a more quicker solution. Now, what is the probability of me getting a plane followed by a plane? That's going to be 12 out of 20 multiplied by 11 out of 19. O means plus. What's the probability of my first chocolate? 5 out of 20, and the second one 4 out of 19. O means plus. First ginger biscuit is 3 out of 20, and the second one is 2 out of
19.
Okay, lovely. Right, we need to work these out. So this is what we got so far, folks. So this calculus cancels this one down for us, and this one, and cancel that one. So we need now do a one big juicy answer for this. So let's have a go. Right. So we have here 33 over 95. Okay, and then we're going to add to that 1, whoops, del 1 over 19, replay, plus fraction button 3, replay, 190 on the bottom. Can you please check the fractions? You all got the same fractions?
Yeah.
Checked it? Okay, we got all that in properly. So that gives us a total of, what was it, 79 out of.
190.
Now that is the probability that everything will be the same. We need to do 1 minus that to give us that it will be different. So we need to go back up to the top line and do now 1 minus 79 over 190. So what is 1 minus 79 over 190? And that will give us the answer over here.
Hi,
So- 1 take away 79 over 190.
Yeah, but what if it's non-calculator? It's 150.
Okay, this is on a calculator paper.
It was still.
Okay, in 1 you have how many, what do you have in 1? How many 190s you have in 1?
190 over
190. So you can replace the 1 with 190 over 190.
Yeah.
So what's 190 take away 79?
Oh.
Ah, what is it?
That's easy.
111.
111
11.
111.
111.
111.
Oh yeah.
over.
109.
That is the answer of the probability of the biscuits not being the same type.
Oh, that's
Oh, easy,
easy.
like-
Yeah, I like the way I said that. That's easy now. Yeah, it's easy now, is it? It wasn't easy before. It's easy now.
Yeah.
Huh? It's good. So we're going to work out in this 5 red pens, 3 blue pens, 2 green pens. The 2 pens are taken at random. And then it takes another pen. Okay. So you're going to work out the probability. Okay. Oh, that's a bit. Probability of the same color, which is equal to what? So what colors do we have?
5.
So we could have the probability that the first one is
Red.
and the second one is also red. Or we could have the probability the first one is
Blue.
blue and the second one is also, or we could have the first one is
Green.
green and the second one is also.
Green.
So this will give you all the possible probability of this getting the same color. So we're gonna consider double red, double blue, and double green. And the O means is this one. It could be this one, or that one, or that one. And now I'll leave you now to finish off the rest of the mathematics.
Is that out of 10?
Yes, they are 10. Don't forget this. This is without replacement. So your second fraction should change. I want everybody to have a go at that one. I'll pause it. Here we go. So the probability of my first red was, well, how many reds do we have?
5.
5. So we got 5 out of 10. Once I pick a red one out, I will only have now how many left over? 4 out of 9. O means plus. The first blue, how many was the blue ones?
3.
3. Had 3 out of 10. When I pick one of the blues, I will only have left over 2. And there's 9 left in there. O means plus. Now here comes the green. How many greens were they? 2 out of 10. When you pick one, there will only be 1 left and there will only be 9 left over. So we have to work all that out now. So that will give you what? 20 over
90.
90. Add 6 over,
90.
add 2 over 90. And that will give you what altogether? Just add them up like that.
28 over 90.
28 over 90. And if you simplify that down,
14 over 45.
14 over
45.
45. And we're quite happy to say that is the answer to that examination question right at the end of the paper, A/A star. Okay, I think how many questions we got left now on the paper?
One more.
Just one more.
You finished quite early. No.
Okay, we're recording now, folks. Are we ready? Okay. So Yvonne has 10 tulip bulbs in the bag. 7 of the tulip bulbs will go into red tulips. 3 of them will go to yellow. Yvonne takes at random 2 tulip bulbs from the bag. So this question is without replacement. So the second fraction should change. Complete the probability tree diagram. Let's choose the right size first of all. So 7/10 is red, so the yellow will be
3, 9.
3/10 for the first part. This part here.
Oh.
Yeah. Now once we take a red out,
Oh,
the
6.
second part will have how many reds now?
6.
We'll have 6 reds. Oh, that doesn't come out very good. Okay, we'll have 6 reds and we'll have how many altogether now?
9.
9. So if that's 6 9, that will automatically be
3 over 9.
3 over 9. Now if you pick a yellow one out for the first time, so that how many yellows do we have left now?
6 over 9.
2
2.
2 over 8.
over 2 over 9.
Why 9?
Because we just picked one yellow.
Yeah, who said 3?
You're not going onwards to the next. It's not third level. It's still the second level.
Oh,
Because you started from here to there.
Yeah, it's 2 over 9.
So,
Okay, that's 3.
and that will be then 7 over
9.
because they got to both added to 1. Now the question is, we have to work out the probability of at least. Okay, now we're recording now. Because work out the probability that at least one of the bulbs will grow into a yellow tulip. So let's have a look what that means. So that means we could have, for example, a red followed by a
Yellow.
yellow, or we could have a yellow
Followed by a red.
followed by a red, or we could have a yellow followed by another
Yellow.
yellow. So we should have 3 possible combinations.
Pass it that way.
Oh, that's really good.
Okay, well done. Excellent. You done excellent maths there. So, okay, let's look at these 3 possibilities.
Yeah, it's really good.
So the probability of red and the probability of yellow,
Really serious.
or the probability of yellow and the probability of red, or the probability of a yellow first and then another yellow. Okay, let's do some math now. So what is the probability of the first red? The first red was
7, 10 out of 3.
7 tenths, and the yellow was
3 of 3 ninths.
3 ninths.
And V equals 21 over 90.
Okay, which equals. Okay, good. What's the probability of a yellow followed by the red?
3 tenths.
3 tenths times by
7 ninths. Equals 21 over 90.
Okay, now the last one probability of yellow and a yellow is
Is 3 tenths times 2 ninths equals 6 over 90.
now it's going to be the probability of this first event or the second one or the third one. So the O's mean
It's 48.
add. So let's have a look what that gives us. So 21 add 21 will give us
It's
42. 42 add another 6 will give us.
48.
So that should give us 48 out of
90.
90. And if you want to simplify it down, it cancels down to
8 over 14.
Yeah.
8 over
15.
15 as our final answer. And that's the end of that examination question. And that's really the end of our lesson. We'll see you folks all next week, inshallah. So please make sure you do your work without copying too much. Okay.